Artificial intelligence. It's a term you hear absolutely everywhere, right? But what does it actually mean? It seems like 1 minute it's about super smart robots, and the next it's about your Netflix recommendations. So let's cut through all that noise. We're going to build a real understanding of what AI is, based on how the experts in the field actually think about it. But here's the thing. Before we can even get to the artificial part, we have to talk about something way more basic. What even is intelligence? Seriously, it's not nearly as simple a question as you'd think. Okay, so let's start with a little puzzle. I want you to really think about this one. Who is more intelligent, a simple calculator or the human being who's using it? I mean, when you break it down, it's a real dilemma. The calculator, it's lightning fast. It's going to be way more accurate than any person. But on the flip side, a human had to invent it, had to build it, and it's basically a paperweight without us. So who's the intelligent one here? The answer is, well, it's fuzzy. And just to make things even weirder, get this. This is Scott Flansburgh. He's a real guy, holds a Guinness World Record, and he can do incredibly complex math in his head almost instantly. They call him the human calculator. So is he intelligent? See, even something as clear-cut as calculation doesn't give us a straightforward answer about what intelligence really is. And that brings us to the core problem here. If we can't even nail down a simple definition for our own intelligence, you can imagine that defining artificial intelligence is going to be a massive challenge. There's just no single easy answer. So instead of getting stuck looking for one perfect definition, what researchers did was develop a kind of framework, a way to organize the different goals of AI into 4 distinct categories. This is how we can finally start to make sense of what people mean when they talk about making a machine smart. And here it is. This is the key. You can basically map out AI along 2 different lines. First is the goal to get the machine to think or to act. And second, are we judging its success based on how human-like it is or on how perfectly rational it is? This gives us 4 buckets. Thinking humanly is about trying to literally model the human brain. Acting humanly is all about imitation. That's where the famous Turing test comes in. Thinking rationally is about using pure formal logic, what some call the laws of thought. And finally, acting rationally, which is about creating systems that just do the right thing to achieve the best outcome. So let's dive into that left side of the chart first, the approaches that are all about us, about humans. This is the stuff of science fiction, right? Can we actually build a machine that thinks and acts just like a person does? And this leads us to one of the most famous ideas in all of computer science, the Turing test. Way back in 1950, Alan Turing came up with this brilliant, simple way to test for acting humanly. He basically said, forget all the philosophical debates. Let's just ask one question. Can you build a machine that can fool a person into thinking it's a person? Let's watch one in action. So here you have a user, Laurent, chatting with a bot, and he just goes for it, asking the big questions straight up. Can you pass the Turing test? And look at this response. You be the judge of that, Laurent. I mean, that's pretty slick. It's witty, it's a little evasive. Honestly, it sounds pretty human, doesn't it? It's doing exactly what a person might do, deflecting the question. So far, so good for the bot. But then Laurent asks a simple follow-up. Tell me about yourself. And boom, the whole illusion just shatters. The chatbot says, I am an artificial linguistic entity. I mean, come on. No human being in the history of the world has ever described themselves like that. The mask just slipped right off. And there you have it, a definite fail. This little exchange shows you just how incredibly hard it is to truly act humanly. It highlights this massive gap between just mimicking human language patterns and actually, understanding the world the way a person does. Okay, so if perfectly mimicking humans is that difficult, what's the alternative? Let's hop over to the other side of our framework, the rationality-based approach. The idea here isn't to be like a human, it's to be correct or optimal. Now, this isn't a new idea at all. It actually goes all the way back to the Greek philosopher Aristotle. He was one of the first people who tried to write down the rules for right thinking, the laws of logic. The goal here is to build a system that follows these ideal logical rules, even if we messy, emotional humans often don't. And I've got the perfect analogy for you. For hundreds of years, when people wanted to fly, what did they do? Well, they tried to copy birds. They built these wild machines called ornithopters with these flapping wings, all trying to act like a bird. And you know what? They all failed spectacularly. And then came the breakthrough. We finally got artificial flight when we stopped trying to copy the bird and started trying to understand the principles: aerodynamics, lift, thrust. The Wright Flyer looks nothing like a pigeon, but it absolutely masters the goal of flying. And that right there is the absolute heart of the rational approach to AI. It's not about copying the messy wiring of a human brain. It's about designing a system that uses logic and computation to achieve the best possible result. Period. Okay, so we've got these 4 different ways of thinking about AI, this whole framework. But what does any of this have to do with the tech you actually use every day? Let's pull this out of the clouds and into the real world. Right now, in the real world, AI pretty much comes in 2 main flavors. First, you have artificial narrow intelligence, or ANI. People call this weak AI. It's AI that's designed to solve one specific problem really, really well. Then you have the Holy Grail, artificial general intelligence, or AGI. That's a machine that could think and reason just like a human. And while we have made incredible progress with narrow AI, AGI is still very much in the realm of science fiction, at least for now. Think about unlocking your phone with your face. That system is a genius at one single task, recognizing your face. But you can't ask it to write you a song or give you directions. It's a perfect example of narrow AI. It's the same thing with the map app on your phone that finds the fastest route to work. It's crunching insane amounts of traffic data to solve just one problem: planning your route. That's another powerful piece of narrow AI that's already all around us. And seriously, the list just goes on and on. The AI that beats the world's best chess and Go players, that's narrow AI. Route planning, the speech recognition on your phone, even AI that can analyze medical scans and spot tumors better than a human doctor. And you know, they're even using it now to generate entire books from scientific papers. It is everywhere. And that's what I want to leave you with. Now that we have this framework, now that we know AI can be human-like or rational about thinking or about acting, it forces us to ask a much bigger question. As we keep building this stuff, what kind of intelligence should we be aiming for? Should we build one that mirrors our own mind, with all of its incredible creativity but also all of its flaws? Or should we aim for something perfectly logical, designed to get the optimal result every single time? It's something to think about.